question we are asked to find out the sum of all the integer values of x which satisfy the two inequalities. The first inequality is log of 2x square minus 7x minus 8 to the base x minus 5 is greater than 0. And the second inequality is log of 3x square minus 15x plus 7 to the base x minus 5 is less than 0. The first thing you should notice is that x is an integer and you want the base of a logarithm to be positive. So x minus 5 has to be greater than 0. Secondly, the base of a logarithm cannot be equal to 1. So x minus 5 cannot be equal to 1. So x has to be greater than 5 and x cannot equal 6. We want x to also be an integer. So there is no integer which is greater than 5 and less than 6. So essentially the value of x has to be greater than or equal to 7. The smallest possible value of x will be equal to 7. Now if you are looking at both the inequalities, the first inequality says that log of 2x square minus 7x minus 8 to the base x minus 5 is greater than 0. One of the first things you should notice when you look at this inequality is that if x is a large number, because x we know is greater than or equal to 7, the value of 2x square minus 7x minus 8 will also be a large number. So to the base x minus 5, you know that you will be finding many integers, many natural numbers which are greater than or equal to 7, which will satisfy this inequality. Let us look at the second inequality. The second inequality shows that log of 3x square minus 15x plus 7 to the base x minus 5 is less than 0. When you have a logarithm where the base is greater than 1 and it is less than 0, it would imply that the argument over here, this has to be less than 1. Or essentially you want 3x square minus 15x plus 7 should be less than 1. Now you should notice that there are not too many numbers which will satisfy this given inequality. Because if x is greater than 7, the value of 3x square will be definitely greater than 15x. Because 3x square will be greater than 15x if x is greater than 5. Here we know that x is greater than or equal to 7. So on some level you should know that there are not too many integers which actually satisfy both these given inequalities. We can easily prove that no integer satisfies this given inequality in a very nice and elegant way. The way to do it is when you have both these logarithms, one logarithm is greater than 0 and the other logarithm is less than 0, and the base for both of them is the same and the base is greater than 1. This would imply that the argument of 2x square minus 7x minus 8 has to be strictly greater than the second argument. That is 2x square minus 7x minus 8 has to be definitely greater than 3x square minus 15x plus 7. Why is this the case? Because the first logarithm is greater than 0 and the second logarithm is less than 0. The base for both the logarithms are the same and the base is greater than 1. The base is a natural number, so it is greater than 1. So now it would imply that 2x square minus 7x minus 8 is greater than 3x square minus 15x plus 7. If you simplify, it will be equal to x square minus 8x plus 15 is less than 0. You can factorize this to equal x minus 3 into x minus 5 is less than 0. So x has to strictly lie between 3 and 5. We also know that x is a natural number, so the value of x will be equal to 4. X has to be an integer as asked in the question. But we also know that x has to be greater than or equal to 7. So there is a contradiction, x cannot be equal to 4, which would imply that no integers satisfy this given, both of these given inequalities at the same time. So the correct answer is 0. We are asked to enter 0 if no such value exists.